Welcome back to Arts Learning. In this video, we'll be looking over mixed circuits and how to analyze as well as solve mixed circuits. As you're going to learn in a few seconds from now, mixed circuits represent circuits that are not purely series or purely parallel. For example, if you had a circuit like this, right? You had one resistor here, right? But then once you hit another node, you get two parallel resistors. And then both of these join and come back. So this you can say is series, right? Because it directly connects to the battery. It's in series. There's no split here, it's just in series. It goes directly through that. But here we have parallel, right? Because this splits into two different branches. So then there's multiple ways we can analyze these, and we're going to look at all the ways, and we can still find the resistance, current, and voltage through each single resistor. It's going to be a bit more harder. Okay. All right. So now before that though, let's quickly recap on the difference between series and parallel. Series circuits, right? They share a node with nothing else attached. Nothing else attached to this node here. But for parallel, both ends on the same node pair, or it doesn't need to be both, it could be multiple. But all ends are in the same node pair, this node here. Same current for series, all the way throughout, but for parallel, same voltage. R adds in series, here 1 over R adds to 1 over R total. And for series, voltage splits, the voltage is dissipated, but for parallel, current splits. Okay, so before we tackle problem, let's go over the method that we're going to use. We're going to find a group that is purely series or purely parallel. We're going to replace that group with a single equivalent resistance. And we repeat until the whole circuit is one resistor. We can compute the total current and then expand back outward. So this is a process of shrinking inward and expanding outward. Okay. So I'll show you what that looks like here. And what I like to do is I like to redraw these circuits in a more digestible way. Okay, so if you look at this circuit here, alright, so the current, the wire originates from the positive side, right? So I can redraw like that. And then either way, it goes through this first 4 ohm resistor. Right, 4 ohm resistor. But then at this node, it splits. It could either go to the 2 ohm resistor or the 12 ohm. So then we have a parallel there. 2 ohm or 12 ohm. If it takes the 2 ohm path, what happens? So it continues along the 2 ohm path, but it splits again. So there's a second parallel branch to either 8 ohms or this 8 ohms, right? So if it goes this way, it goes like that. If it goes this way, it goes like that. So we have another branch, both 8 ohms. Okay. And then from that, so once the current, so this is going to be a bit hard to explain, but once this current, okay, this one passes through the 8 ohm resistor, it continues to the same spot as the 8 ohm resistor. So they're both in parallel, okay? But once these two currents join and they go through here, they reach the same spot of this 12 ohm resistor. So there's two ways you could have reached this spot, right? If you went from here, you went along the 4 ohm, you could have directly gone downwards. Or you could have gone all the way around, but you could have still reached the same spot. So the 12 ohm resistor is going to intersect with the current from these two, but all the way at the end at this node here. Okay. And then that's your circuit. What I did was I basically split the circuit up. Okay, I broke it up into pieces that we can analyze with. So first let's fill out what we know here. R1, 4 ohms, right? R2, 12 ohms. R3, 2 ohms. R4 and 5, 8 ohms each. Okay, and then the current through R4 we're given is 1 amp. So we don't know anything other than that. That's fine. So now let's find the equivalent resistance of this entire circuit. So like I told you, right, the circuit can't see the circuit. I mean, the battery can't see the circuit. It doesn't know whether it's parallel or series. It just feels the amount of force it has, okay? It just feels that there's this amount of resistance, and then it generates a current equivalent to that. I mean, corresponding to that. So we need to find the equivalent resistance of this. So first the 4 ohm, okay? We will leave that in series. But then we can simplify one of these two branches, right? Leave the 12 ohm right now. But here we have a 2 ohm, right? And then we split that into 2 8 ohms. Correct? So you go like that. But each of these 8 ohms, right? They're a parallel branch. And how do you calculate the equivalent resistance of a parallel branch? 1 over R total is 1 over R1 plus 1 over R2, right? And actually, let me erase this now because I don't have enough space. Okay. Right? So then you can do 1 over R total of this specific, okay? Consider this its own circuit. We're looking at this as its own circuit. Is equal to 1 over 8 plus 1 over 8, which is just 1 over 4, right? And if 1 over 4 is equal to 1 over R total is equal to 4. If you flip them both, right? 4 ohms. So this entire piece here, right? I can just replace that with what the circuit sees. I mean, with what the circuit feels. It doesn't see that it's a parallel branch of 8 ohms for each. It only feels that it provides an equivalent resistance of 4 ohms. Okay. And then if these two are in series, we can add them up, right? Because they're in the same series. That's how we find out the total resistance for series. So consider this as its own circuit. How do we find the total resistance? 2 ohm and 4 ohm, right? 6 ohms. So that's what the circuit sees. I mean, or feels. 12 ohms. Then 4 ohms. Isn't this similar to our first predicament? We had the 8 ohm resistors and we simplified them, right? We can similarly simplify this branch, this entire thing here. So we're going to take the equivalent resistance of this parallel circuit here, which is going to be 1 over R total is equal to 1 over 6 plus 1 over 12, 2 over 12 plus 1 over 12, or 1 over 4. So R total is 4 ohms, right? Okay. So then we can similarly just replace this with what the circuit feels, which is 4 ohms, right? So 4 ohms there. And then we can still simplify this further. If you two resistors are in series, what do they add up to? There's no 1 over RT here, right? It's just both of them added up. So it's basically 8 ohms. The circuit doesn't see this, I mean, the battery doesn't see this entire messy thing. It only feels 8 ohms of resistance and it gives that. So if anything, what I did or how I simplified the circuits was confusing to you, we'll have more practice with it, right? But also make sure to check out my previous videos where I define what parallel is. Of course, I didn't cover how to mix them together here, but you just saw, right? You break it down, and they're going to build it up just like that. So the total resistance here is 8 ohms. Okay, 8 ohms. And then we can find stuff from that. So what can we navigate from that? So now that we know the total resistance of 8 ohms, we can break it down further or build it up from there. Okay, we broke it down to the most basic part of it, but now we can find so we're given the current, right? We can build up from there. We need to find the voltage of this battery given a current 1 amp in, let's see, so first the 4 ohm, right? Let me draw the same drawing again. 12 ohm here, 2 ohm here, the same parallel split here of 8 and 8, and then they all connect. Oops, that was a flimsy connection. Okay, so with this, if we're given that the current in R4, so R4 over here is this resistor, or either of these, right? It doesn't really matter, but because they're both 8, R4 here, we're given 1 amp. So that's the current in this resistor. How are we going to find the rest of the currents? So first off, right, given that we have 1 amp here, remember what happens when you have a parallel circuit. So just look at this as its own parallel circuit. Okay, forget about everything else. Take a zoom in on that specific parallel branches. The current splits, right? But the voltage is the same. So here, if we wanted to find out, so this is 8 ohms, right? And 1 amp here. So the voltage, right? The voltage is going to be the same through both branches, for both branches, right? And how are we going to find that out? So V is equal to IR. We can just use this branch here. I mean, we don't need to, but once we find out the voltage from that, right, we know that this voltage here has to be the same voltage here. So let's find that out. So that means we have 8 times 1, which is 8 volts, okay? So I know that there's 8 volts of battery running through this little wire here, and then it splits, okay? So if you have 8 volts here and 8 ohms, what's the current going to be over here? So I is equal to V over R, 1 amp, right? Because 8 volts over 8 ohms is just 1 amp. And in this case, the current is the same, okay? You don't want to assume that the current is going to be the same in both. And what you want to remember again is, so actually, I shouldn't have erased that 1 amp for here. Let me write down what I have so far. For R4, we have 1 amp, 8 ohms. And the voltage was 8 volts, right? And for R5, we had similarly 1 amp, 8 ohms, and 8 volts. Okay, so almost the same. But remember what happens, right? The current in is the current out. So 1 amp and 1 amp, since it's a parallel circuit, what's the rule for current? The current adds / divides, right? When it goes into a parallel branch, it splits. Given the voltage, we can find the current in each individual branch, but it's going to split. All right? So over here are actually current adds. Yeah, so how many amps of current must we have to split into 1 amp on one side and 1 amp on the other side? 2 amps, right? 1 amp plus 1 amp, because that's how much we split. 1 amp plus 1 amp is 2 amps, which makes sense, right? We split 2 amps into 1 amp each, and we were able to go like that way into both these branches, okay? So 2 amps is coming in. Right, so now with that, we can look at a bigger piece of the puzzle. Now we can look at the 2 ohms as well as the 8 ohms. Okay, so there we go. So from here, right? From here, 8 ohms, 8 ohms here. What can we deduce? Well, we know that there's 2 amps of current running over here, right? Because that's split into 1 amp in each of these. And how many volts did we know was running through here as well? We knew that it was 8 volts. 8 volts dissipated for this section. Right? 8 volts dissipated for that section because it's split into both of these. So what can we deduce? Let me erase this stuff. What can we deduce about this? If there is 2 amps going through both of, so if we represent this, right, this entire branch here, we can simplify these 8 ohms, similarly like what we did before, right, nothing different here, into the 4 ohm resistor. 1 over R total is 1 over 8 plus 1 over 8, right? I didn't do anything, I just simplified that branch. So we know 2 amps of current runs through both of these. And what's this called? This is called R3, right? 2 amps. Oops. So R3 is 2 amps. And if you don't understand why, remember, right? If 2 amps was coming into the parallel branch and then it split, since this branch is in series with that branch, with the parallel branches, right? This branch is in series with that. This branch is also going to receive 2 amps because it's in series, right? So then the voltage through this, we can find out, right? Voltage is I times R, 2 times 2, 4 volts. There you go, right? There you go. So we're not done yet, but we have almost half of our chart filled. And then from there, we can navigate further. So we have that 2, then we have that 4, right? But that itself was split alongside the 12 ohm branch. So this 4 ohm is actually the 8 split, right? I just simplified it and wrote the equivalent resistance down as 4. And then, of course, we have at the very start, we have the 4 ohm resistor before we do anything, right? So now what do we know? Since there's 2 amps of current running through this side of the circuit, right? This side of the thing, of this upward branch of this entire parallel branch, right? Then what else can we deduce from that? So we know there's 2 amps of current running here. Do we know that 2 amps of current is also going to run through this 12 ohm resistor? No, right? Because the current is going to split. So it could be 2 amps, but for sure we don't know whether it's going to be 2 amps, right? So we can't say that there's 12 ohms, 2 amps going through here. But what we can do is we can find the voltage dissipated along this entire circuit. We know the voltage is going to be the same. And pay close attention here because this part gets a bit tricky, right? So we know that could simplify to 4 ohms, right? The equivalent resistance of that 8 branch was 4 ohms. So what can we do from there on? Well, we can add these together, right? So the equivalent resistance of this entire upward branch is actually 6 ohms, right? And then the downward is 12. So if we have 2 amps of current running through the 6 ohm resistor, I mean the 6 ohm total equivalent resistance there, then what's the voltage dissipated here? Voltage is equal to IR, right? The total voltage dissipated is 12 volts. And there's another way you could find that, right? If you remember here, when it was the 8 ohm resistor here, 8 ohm resistor here, right? For both of these, we said that 8 volts was coming in and split into both of them, right? So 8 volts was dissipated along this one. And then we know 2 amps was coming here, so we're able to figure out that this is 4 volts. So for this entire branch here, 4 volts plus 8 volts have been dissipated, right? Which is 12 volts. So we could find it out that way, or we could do what I just did. Okay, so let me erase this and then write back the 8 ohms there. Okay, so there you go. From that, we know that over here there's a total of 12 volts, right? So if 12 volts is coming in on one branch, the 12 volts is coming in on the other branch, because that's how parallel circuits work, right? 12 ohms here. So here over here we had 2 amps of current, but here we're going to have something different. But we know 12 volts is coming into the 12 ohm resistor, right? So over here we can write 12 volts. Or actually, since I didn't write any, we already know the units, we don't need to write all that. Okay, so there you go, 12 volts. How do you find the current through that? Well, current is voltage over R, right? I is equal to V over R. So I is equal to 12 over 12, 1 amp. Actually, let me not write the units there either, because we already know the units over here. It's given up above. Okay? And we're almost done. We just need to find this final branch here. So what do we know here? If there's 1 amp of current running through this side, this downward side, right? And there's 2 amps of current running through this upward side, then 2 amps plus 1 amp is 3 amps, right? That's the total current. So there was 3 amps of current running through here, and then it's split up into both of these, into 2 amps and 1 amp. Okay, so there was 3 amps of current running through here initially, and then it's split up into this 2 amps and 1 amp, right? So 3 amps of current was running through here. Since this 4 ohm resistor is in series with this, right? It's going to be the same current. It's not a parallel, so it's going to be the same current. 3 ohms was over here, so 3 amps was over here, so 3 amps was over here. This resistor would experience 3 amps of current. Okay? So then 3 amps, what is the voltage going to be? The voltage is going to be, right? The voltage is going to be I times R, which is 12 volts. So the total battery voltage, right? The total current here was 3 amps. And then from that, we know that this over here, this has to be 24 volts, right? Because 3 amps was in series at the start. So that means it's the amount that we got, right? Every alley along the way, we've been breaking up that single 3 amps we were handed at the start. Okay? With that 3 amps, we did that. So we know that's going to be the total, because as I explained, right? Since we have 3 amps at the start, we're going to have 3 amps at the end. 3 amps throughout the entire circuit. This 3 amps was just broken up by all these multiple parallel branches. So then we could find the total voltage of 24 volts. And there you go. That's your total battery voltage. Okay. In the next video, we'll tackle this 10 resistor circuit here. So stay tuned for that one. And then we're going to go into diamond circuits. So not circuits that you need some extra knowledge for. Okay, same basic knowledge of parallel and series. This is the first level of circuit analysis. We'll stop here and we'll start here, right? And we're going to go over the hardest questions possible there. Make sure to give me a like and subscribe, and stay tuned for those videos, because circuit analysis isn't over yet. We're also going to go over diagonal branches. So yeah, stay tuned for that.